Okay, actual students, this is the last lesson for actual students in Unit 2. So this topic is finding where graphs meet. And I do believe that you guys are very familiar with the points of intersection of two functions. If two graphs cross each other, we know that x-coordinates of the intersection should be the roots of the equation f of x equals g of x. So here, we use this idea to solve any equation like f of x equals g of x. We can graph the left side function and the right side function on the same coordinate system. And the x-coordinates of intersection of these two graphs are the roots of this equation. So right now, we look at this example. Let's draw the functions y equals 1 over x and y equals 2 minus x on the same set of axes with the domain -4 to 4. So there is a domain for the graph, which means you don't have to graph too much. That's all what you need. If you are not familiar with this graph, you can use the graphing calculator to help you graph this hyperbola. But on your graphing calculator, I hope that you can set up the restricted domain with x minimum equals -4, x maximum equal 4. But here, I will use the manual way to graph this rational function. Y equals 1 over x, and we know the undefined value of x in this function is x equals 0, which means x equals 0 is the vertical asymptote. If the bottom x cannot be 0, 1 over x cannot be 0 either. That means y cannot be 0. So y equals 0 becomes the horizontal asymptote. Then I can use some points to help myself to get to the trend of this graph. So let's say if x is 1, 1 over 1, y is 1. X is 2, y is 1/2. X is 3, 1/3. Anyway, when the x value is getting larger and larger, the y value is getting smaller and smaller, approaching 0. Here, if x value is 1/2, the y value becomes 2. If the x value is 1/3, the y value becomes 3. Anyway, you will find on this side, if the x value is getting closer to 0, the y value is getting larger and larger, but never cross the vertical asymptote. So that's how I can graph this function in the first quadrant. The other part of the graph is in the third quadrant. So if x is -1, y is -1. X is -2, y is -1/2, then -1/3. So if the x value is getting closer to -infinity, the y value is getting closer to 0. Let's look at this part. If x is -1/2, the y value is -2. If the x value is -1/3, the y value is -3. Anyway, if the x value is getting closer to 0 from the left-hand side, the y value is getting more and more negative. So that's the graph for y equals 1 over x. Then, this time I will use the blue color to graph this linear function. And you can change these two terms to negative x plus 2. So based on this form, you will see the y-intercept of this line is 2. And the slope is negative 1. That means you go down 1, go right 1. Down 1, right 1. Down 1, right 1. I think we have enough points to get to the line already. Okay, so this blue line is y equals 2 minus x. This is the graph. But if you only needed the domain from -4 to 4, you can even erase the further part. You can stop the graph at -4 here. And here, you can erase the part greater than 4. So you can stop your curve here. So that's the graph from -4 to 4. Okay, that's the first one. B, hence find any solutions to the equation 2 minus x equals 1 over x on the domain. So we will find this is the hyperbola function. And this one is the linear function, which is the blue line. And when we graph both of these two functions on the domain, we find that the blue line touches the hyperbola at one point. And we can find this point very quickly. This point is 1, 1, which means x equals 1 is the solution for this equation. Okay, right now, C, this question is more challenging. We need to look at the domain for all real numbers. So that means this time we need to extend this side and extend this side, and the blue graph can be continued forever. Okay, so we look at for what values of k does x plus 1 over x equals k have one solution, no solutions, two solutions. Let's look at what does this equation mean. X plus 1 over x equals k. This is an unknown variable, and I need to look at what the k value is. This equation has one solution. What the k value is, there's no solution. What the k value is, there are two solutions. This one is really tough for me. We even cannot use the delta discriminant to determine the k value based on the nature of the roots, because this equation is a rational equation instead of a quadratic equation. So we will use the graphical method to help us figure out what a k value is. The equation has one solution. What I will do here is, based on these two guiding questions, I will split the equation into this way. Okay, I keep 1 over x on the left-hand side, but I move this x to the right side. It becomes k minus x. So right now, I have two functions. The first function is just the red hyperbola. And the second function is k minus x, which is the same as negative x plus k. So right now, I have this function graphed already. And for this function, we know this is a linear function. Although we don't know the y-intercept value, k, here, but we have a fixed slope value. this slope is -1. That means if the k value is changing, all those lines should be parallel to this blue line. And this blue line shows me when k is +2, y-intercept +2, this equation should have one solution. But let's look at this one can produce one solution if I move this blue line parallelly. Okay, if I say I have the blue line, as long as it's parallel to this blue line, I can let this blue line touches this curve at one point. In this case, for this blue line, the y-intercept value is -2, which means when k equals 2 or -2, the equation has one solution. Okay, what are the k values that can produce the equation? Has no solutions. I find all the lines between these two blue lines. You can see all those black lines do not intersect the red hyperbola at all, which means if the k value is between -2 and 2, this equation has no solutions, no points of intersection. The last one, number 3. Let's look at what are the k values. The equation will have two solutions. I find that I move the lines upward. As long as this line with the same slope -1 is above this blue line. Or I move this blue line downward. So you will see you keep the slope, but the k value is less than this k value. This black line intersects this part of the hyperbola at 2 points. So from the graph, I can see when k value is either greater than 2 or less than -2, the equation has two solutions. I know this question is pretty challenging, but I still hope that you guys can get more understanding through practicing those homework questions. Okay, if you need help, please let me know.